Okay, this is 2.2 homework help. A lot of these problems are just going to be application problems because we've already pretty much studied polynomial functions, which are very similar. There's a few other cases where you can have now fractional exponents and negative exponents, but the best way to handle these is just to do some problems that involve various types of power functions. So here's a random example then. Let's say that we have a cube for this first problem, and we're given that we're going to put smaller cubes inside of this one. So let's put a smaller cube inside of here. And the question is, how many of these cubes can I fit inside if the smaller cube has a surface area of 54 and the larger one has a surface area of 216? All right, so first of all, if a cube, if you call like this side x for a cube and this side x, then it's not hard to see that that the surface area would be, this would be x squared, so each side would be x squared, and there's 6 sides for a cube. So it's not hard to see the surface area would be 6x squared for both of them. So if you want to find what the side length x would be for both of these cubes, you can find it real quick by just dividing by 6 and taking the square root. Okay, if you do that for the first one, you get 3 for x. And for the next one, you get x equals 6. So the bigger side has length 6 for each side, and the smaller one has length 3. And so we have a situation where one cube has sides that are twice as long, in which case it would have 8 times the area. You could actually fit 8 of these smaller cubes inside of the larger one. So our answer is 8 here. All right, you could, another way to do this problem is look at the ratios of length, area, and volume. So we'll talk about, if the ratio of length is a to b, the ratio of area is a to b squared, and the ratio of volume is then a to b cubed. So they gave us a ratio of surface area, which is 216 over 54. If you take the square root of this, then you get actually 1/2. So you can see the ratio of length here is 1 to 2, which we already knew, which makes the ratio of volume then this cube, which is 1 to 8. So we're going to fill this out quite a bit because it's our relationship between length, area, and volume. And it's pretty easy to see it from this. Well, here's another way to look at it. Area is length times width. So if you make the length twice as big and you make the width twice as big, you've now made the area 4 times the original area. So for volume, you just do that again. You'll have 2 times 2 times 2, which is 8. So you can see how when you make the length twice as big and the width twice as big, and the height twice as big, for example, times length times width times height, you can see then how you have 8 times the original length, width, and height. So when you make something twice as long, you actually increase the volume by 8 times as much. All right, so this is supposed to be cubed. Sorry, right here, this is cubed. Those are our relationships, and we'll do this quite a bit. Hopefully that'll make sense. All right, for the next problem then, at a party your friend tells you that the banker told her an investment will triple in 10 years. What's the annual interest rate? Well, however much you're going to invest times the rate, you're going to do that for 10 years, so each year you're going to be multiplying by that rate. So I'll put a 10 there, right, because it's 10 years, so it's the 10th power. You multiply by r 10 times. And that's going to triple, so you're going to end up with 3 times whatever you started with. Okay, so this is the equation you're solving. Power function with an exponent of 10 here. P's cancel, and you get 3 equals r to the 10th. I'd raise one side, both sides to the 1/10 power. It gets rid of that 10. And you end up getting r equals 1.116 for me, 1, which that r represents just the original amount. That 1 represents the original amount. This is my interest rate right here. So it's actually 11.61% interest, right, added on to 1 each time. The next problem is probably a problem you're familiar with from geometry. As you're hiking and you look at a redwood tree, here's the tree with its shadow, here's you with your shadow. You know those are similar triangles, if you remember? So it says the shadow of the tree is 245. It says that you are 5 feet 9 inches. We're going to have to convert that to just be in feet. And this is your shadow 7 feet. So 9 inches, let's get that in feet, multiplied by 1 foot over 12 inches. Inches cancel. And you can simplify 9 over 12. 3 goes into 9 3 times and then 12 4 times. So it's 3/4 of a foot or 0.75. This is going to be 5.75 feet. And call this x and set up your proportion. Do like, it doesn't matter, you can do this over this equals this over this. So x over 245 equals 5.75 over 7, right? Because we know that if these are similar triangles right here, then ratio of corresponding sides is equal from geometry. So you can solve for x right here, and that gives you the height of the tree. All right, so for the next problem then, problem 4, it says, your friend has a cube of gold. You have a cube of gold that weighs twice as much. So I always spell this length, area, volume relationship. It helps me make sense of this. I know the length ratio, whatever that is, the area ratio is that ratio squared, and the volume is that ratio cubed. So they gave me the volume ratio, which is weight. Weight is equivalent to volume for our purposes, three-dimensional. So it says your cube is weighs twice as much, so we're going to make the ratio 2 to 1, which would make the length ratio then the square root of 2 to 1. I'm sorry, the cube root of 2 to 1. I'll just raise that to the 1/3 power. And then you square that to get the surface area. So it'd be 2 to the 2/3 actually, because if you square this, the 2 goes in the numerator spot. So they want to know the cube is how long in comparison. Well, it'd be 2 to the 1/3. This answer would be 2 to the 1/3. And then it has length times the surface area, that'd be 2 to the 2/3. And you can enter that in as a decimal. And the last question is really tricky. It says the ratio of weight of your cube to the surface area of your cube is, well, if you call your cube 2x because it's twice as big as your friend's, it weighs twice as much. To the surface area then would be 2x raised to the 2/3. And then I want you to compare that to your friend's, which your friend's weighs only half as much, so x. And then that'd be x to the 2/3. So if you do this division, you'll get the right answer. So multiply both sides by the reciprocal of this, which is x to the 2/3 over x. So you move that to the top, and then this reduces. And when you distribute this, this is going to cancel with the x to the 2/3. So you're going to end up having 2 over 2 to the 2/3, which you can enter that as a decimal right here, and that'll give you the right answer. Okay, the next question says you have 2 boxes of the same shape that hold flour. The larger box holds twice as much as the smaller one. Once again, I always write this out because there are relationships. Whatever the length ratio is, the area ratio is that squared, and the volume ratio is that cubed. They give us the volume ratio because they say the larger box holds twice as much flour, so it's 2 to 1. So if I want to find the length ratio, that's 2 to 1 or just 2. Doesn't matter, you don't need a 1. Cube rooted. And so I'd square that then, so it's 2 to the 2/3 again for my area ratio, which is what they want because they say that it would take you how much paint to paint the larger box. So that number is, they're asking for the surface area ratio because your paint is equivalent to surface area. You're covering the outside of the box. Okay, the next problem then says the stopping distance d is directly proportional to the square of the speed. There's our equation. And it gives us an ordered pair. It says the car requires 65 feet to stop, so 65 goes in here. And when it's going 60 miles an hour, that would go in here. That would help us find k if you just plug this in and divide. And that gives me a k of 0.01806. Webwork's picky, it wants a lot of decimal places. So if you enter that in here, that's your equation. And then it gives us another question. It says when the car is traveling 74 miles an hour, so now just plug in 74 for v, and you'll find the corresponding distance, which for my case, it's 98.87. So sometimes Webwork's really picky about how many decimal places it wants, so be careful. All right, the next problem says the energy expended by a dolphin is proportional to the cube of the speed. So that'd be the equation. So this is like E of V because this is our function notation where our function independent variable is V and our dependent variable is E. So E varies as V. So we'd say E of V equals K V cubed. The next one says an aircraft takes off at speed V, uses up distance R. It says R is proportional to the square of the takeoff speed. And it gives us K, is 0.164. And then it says if the aircraft is taking off speed at about 210, how much runway does it need? So plug in 210 there, that should give you your R. Next problem says a square has side length x right here, and then obviously the area is x squared. By what factor does the area change if the side length is doubled? So if you double this now, then it would be 2x squared. So the area would end up being 4x squared, so it's 4 times the original x squared. So I don't know if I could show that better, but there's the original. And then the new would be area equals 2x squared, which is 4x squared. So if you compare the original to the new, it's 4 times. And then what factor is area change if the side length is cut in half? Well, that'd be the same thing, only this time you'd have 1/2 x squared, which would lead to x squared over 4, so it's 1/4 as much. Next problem wants to write an equation for y in terms of x. It says y is proportional to the cube of x, and then it gives us the constant of proportionality is -0.35. So if you enter that in, that should work. Next problem wants to solve the equation for x. So we have w equals 2 pi times the square root of x over t. So let's divide both sides by 2 pi. And then let's square both sides. So you get x over t equals w over 2 pi squared. And then multiply both sides by t. And that should work. So you end up getting x equals this. That should work to enter that in. Next problem wants to identify the exponent and the coefficient. So p equals 6x to the first is what we have. The exponent is there, and the coefficient is right here. Next problem says, look at this. You can do this in Desmos and put in sliders. It's pretty straightforward. I did this in the notes if you watch that. But if you go to Desmos, I'll type in y equals k x to the a. And they'll automatically ask you if you want sliders. Just put sliders on all of them. And then you can see what happens as you change these. They actually use p instead of a. It doesn't matter, obviously, but I'll put a p there. Then add slider for that one. So they said what happens is p is greater than 1. Actually, I'll do p equals 2, so it's a parabola, because that seems to be the graph that they have on Webwork. So you can see this one is more like a parabola, so it would be c, for any time p is greater than 1. When p is a fraction between 0 and 1, it's going to be it's going to be b, and I can show you that on Webwork as well. If p is the number between 0 and 1, you get the square root function. When p is equal to 1, you get a line, so that's going to be d, and you can try that on Webwork as well. P is equal to 1, you get the line. And then if p is less than 0, like let's say, an example would be y equals whatever, if k is 3, and then x to the -1, let's say. That's really 3 over x, so that's the reciprocal function. That's a, obviously. It looks like that and like that. And you can try that on here by changing p equal to -1, for example. And you'll see that it's a hyperbola. All right, I hope this helps.